topic, which is development of highway materials for enhanced roadway sustainability. Let's quickly take a pep talk to be delivered by Engineer Dr. Ayo TB. Let's put our hands together for him. He's going to give us a pep talk in 2-3 minutes, and then Dr. Amin will continue. Thank you.
Good afternoon, ladies and gentlemen. You are welcome back from your lunch. Unfortunately, Dr. Patrick is not here. I was trying to tell him when he was looking for the definition of Poisson ratio. I told him that he wouldn't have gone that far. Most of us, before the lunch, we know our Poisson ratio, but all of us have eaten now. If we come and measure our Poisson ratio now, we'll see the difference. And next time, what he should do is just tell one slim person to stand up with flat tummy like my own, and some other person with like this. That's simply the definition of Poisson ratio. The other one is, I was cracking jokes with my chairman the other day, that he has his beard is black and white. Then he told me that, hey, yo, this your white beard is AI generated. So I now ask Prof, can AI generate white beards? Let's go into the main thing now. Okay, by tomorrow, after meal, we'll display we'll send it this evening to all the general platform. Everybody will go through. Then after meal tomorrow, we'll display it like this, line by line. If you have input, we'll correct it. So at the end of it, we'll have the communique of this conference as I suggested yesterday. So at the end of it, we'll be working the NIHTE, and all of you will be working together so that by this time next year, before we start, we'll present what we have achieved in the communique. Thank you. Then the last one, it goes like this. I call it charge series, but you people call it pep talk. Retired or emeritus, the choice is yours. Retirement is not synonymous with death. Retirement does not tantamount to incapacitation. May I use opportunity to admonish those who are in active service and those who have retired, not to be discouraged by the word retirement. The word retirement should not release any spirit of phobia to you. Retirement is only a jargon by employer for employee or paid worker. It is a word meant for those who found themselves in paid employment or civil service. Civil service conception of retirement is demoralizing. Those who are self-employed never retire after doing business for 35 years, nor close down their business at 60 years of age. I don't want to know the way you consider the word retirement, but I consider retirement to be a phase in life, just like the completion of primary school, secondary school, university, civil service employment, and non-employed. To worsen the case, as you are retiring, your MDA will demand for your post-retirement abode for them to pay you and your family to go back to your village. Literally meaning your service is done. I am done and dusted with you. Go back to your village and die. Note, you only retire from their own service, not from your profession. I don't have a Shege. I don't have. Okay. You see, I didn't see. Okay. That's why in most cases, I prefer to borrow the word from the university, where a retired professor is called Professor Emeritus. You hardly hear of a retired professor. Instead, what you hear is Professor Emeritus. That's why I prefer using it, Director Emeritus, FEMA, not Director Retired, instead of Retired Director, FEMA. Don't also forget that in civil service, you are directed, but when you retire to incorporate your own business, you direct your affairs. It is even an upliftment from being an employee to an employer of labor. Retirement is like the release of an eagle, which has been operating in a confined environment, but has now been released into an unconfined hemisphere, where the highest horizon becomes his abode. But I come to observe one thing, that sometimes those in active service seem to despise the retirees. For an active civil servant to despise a retired civil servant is like trying to despise death. Retirement is sure for every civil servant, as death is sure to every human being. There is this, the other observation I've made, also that when a civil servant retires, some people feel he or she should not be seen again in his place of work. Let's look at this analogy. Let's look at this analogy. Okay. Yeah. Let's look at this analogy. For those who were brought up in the village, just like me, we spent 6 years in primary school, spent another 5 years in secondary school. Let's say you had a university in your own town, 4 years. That is, it means that you spent maximum of 15 years in the village. In the civil service, we spent 35 years, like I spent, in our places of work. I therefore conclude, if somebody cannot stop me from going to my village, where I spent only 15 years, when I retired, nobody should stop me from going to my place of work, unless such a person retired was not treating his subordinates fair. Let me also sound a note of warning here. Never retire to village if when in service you were not closer to those in the village. The result will be that of living in seclusion, loneliness, social alienation. And these are the root causes of depression and terminal disease, leading to early death of most retirees. Does it make sense?
Please, a round of applause for Engineer Dr. Ayo TB, Director Emeritus. All right, that was a wonderful one. We now bring back on Dr. Amin Aknok, who will take us development of highway materials for enhanced roadway sustainability as our last training for today.
So good afternoon, everyone, again. Anybody still awake? Anybody's willing to stay till 7 p.m.? 7 is okay? Or right before 7? Is there any football game or anything today? Any football game or any important event? You know, in America they call our football, it's soccer, right? And the football is this one. Do you know why it is football? What's the name? What's the name coming from? It's a little weird, and that was my first question for people in the US 25 or more than 25 years ago when I moved. I told them, you guys are insane. They said, why? I said, you call it football, you play it with your hands. So why is that? So they didn't know, and I kept researching. It was really a strange answer that I found. It's not football like football, it is 1 foot long ball. The length, you know, if you take a section in the middle of the ball from this edge to this edge, 1 foot, 12 inch, 30.48 centimeters. So it's a 1 foot long ball, but nobody, even my students, you know, sometimes on, you know, when I'm exchanging jokes with them and I tell them, why do you call it football? They, we don't know. I tell them it's a 1 foot long ball. So they play it, they call it football, but they don't know why it is football. But the real football, they call it soccer. Right? So, just one extra piece of information. So, it's good to know. If any of you encountered an American in his workplace and, you know, ask him, and I would say 90%, he will not know the answer. So, okay. Gentlemen, is the presentation ready? Excellent. So, our last presentation for today, on the schedule that was supposed to be the first, but as you will see, this is nice and light. A lot of the information that is here, you already have heard it before, whether in some of my slides or Dr. Patrick's slides, and there is no math. Basically, we're all civil engineers. A lot of us, or majority are, and have good background in materials. So some of these information will not be new, and even the new ones will sound and look intuitive. Not like AI per se, where there is a bit of mathematics and new concepts. So that's why I asked Engineer Isa if we can kind of shift number 4 to make it 1 and number 1 to make it 4 as a nice and light conclusion for the day, and he graciously accepted this. So let's rock and roll for, I mean, not a long period of time, I understand. A lot of us want to go home, and I also need to keep some time for Q&A for the whole day, including MEPDG. I'm not sure if Dr. Patrick, he has an important, I think, web meeting or phone call. But anyway, I can also answer questions relevant to that presentation if he's not back. His MEPDG presentation. So as we all know, our pavement with either flexible or rigid. Flexible, it's more or less asphalt concrete or binder or bituminous material, and rigid primarily is Portland cement. Now we are using the RCC. And I'm not sure if you have heard about what the Italians are trying to do. It's good to mention, since we're talking about new materials, they're doing what they call the self-cleaning roads. Self-cleaning or photocatalytic roads. Basically, some materials have the tendency to eat up dirt, like it decomposes dirt in the presence of sunlight. We all know, we studied in our primary school, that there is photosynthesis, like green chlorophyll. When you give carbon dioxide and sun rays, you have oxygen. So there are some materials that does the same, but instead of changing carbon dioxide to oxygen, they eat up the dirt. I mean, it's the dominant cement company on earth. It's Ital Cementi. It's Italia, like Italy, Cementi, like cement. So they already have prepackaged Portland cement with incorporated photocatalytic components. There are lots. I personally did some research using titanium dioxide, you know, micro to nano size. Nano will be expensive, but to do on a practical level, you know, micro titanium, it's not that expensive at all. And if you incorporate it in rigid pavement, especially on the top 1 inch, that's more than enough. If you have oil spill, if you have dirt, if you have type of dust. You know, some countries are doing that on the facades of the buildings. If it's white color, instead of having people climbing on scaffolds and, you know, spraying and cleaning, it's more risky, more time consuming, more expensive. They use photocatalytic concrete that kind of self-clean itself. Okay? So close to 4 million public roads or public road miles, or 8.25 million lane miles in the US. The paved accounts for 60%, and out of, or 64%, out of the 64%, 93 to 94, I think this is about a year or two ago. Now we're talking 92 to 93. I think 93 is a more fair number than 94 are soft pavement or asphalt. That includes all the types. Hot mix, cold mix, well, I wouldn't say cold mix, but warm mix and hot mix. We've seen there is dense graded, there is open graded or gap graded, there is porous. It depends on the function. Do you need it mainly for drainage? Do you need it mainly for fighting of ruts, etc.? But hot mix, warm mix together add up to 93. Rigid pavement, including Portland cement, plus RCC, it is accounting for about 7%. The self-cleaning, it came to the US, they used it in one state, the state of Missouri, and it's like a pilot project, so it does not represent any percentage. It's just more of a under exploration right now. But who knows, maybe in 5 years, you know, the pace is getting so fast. Maybe in 5 years it grows the norm in the rigid pavement as well. Driving, 3.2 miles, 3.2 trillion miles. The amount of losses is 130 billion in dollars. Again, why is this losses? When you remember the life cycle cost, you know, the cost at any point is not only the cost of construction, it's not only the cost of equipment, it's not only the cost of material. You have to consider user's cost, the commuter's cost. This cost, it includes the regular expenditure, gas, oil change, regular maintenance, or it could be the cost when you have a detour or a blockage or capacity restriction, a 4-lane road, you cut it down to 2 and you are maintaining 2, then that congestion results into more gas consumption, time loss, and time equals money. So all this has to be accounted. Also the accidents evolving from poor conditions, especially like ruts mainly. I wouldn't say a regular crack or raveling would do, but accidents, you know, they account whether you have a mechanical problem or like a damage for the equipment, which is your vehicle, or human injury, that's another cost, or death, God forbid, which is the maximum cost incurred. I mentioned this before, and this is a better looking pie chart. Only 42% looks good, more than 58 or 58% are not in good condition. Remember, our overall is a case of D. If you go to the first presentation, D means it's failing or about failing. So it's really in poor condition. C is mediocre. F is clearly failing, that needs full or new project. It's not worth maintaining, just replace. So it is disastrous. The amount of money available is not covering except 60% of the needs. I've been through this slide before, and this is one of the slides you can refer to when you come up with a decision, or it could be an algorithm using our terminology of today, which way you go. So basically, if you are targeting a thinner layer on your highways to not affect bottom layers, sub-base and base, or to not affect your ground, you better shift to rigid pavement because of the better distribution of your loading. Again, stress is force over area. Larger the area, lower the stress. Rigid pavement is the answer. If you have poor geotechnical condition and you want to not invest much in replacement and compaction, also rigid could be the case. Now, the opposite would be if you have issues like frost heave, because you're pushing from down up. Rigid pavement is not gonna flex with you, but flexible pavement is gonna help. So again, this slide basically is a way of determining which way you go given the criteria you have. Other thing for the quality of the highways are the smoothness. If you remember the drainage, if you calculate the drainage, anybody is interested in hydraulics? Or we just, yeah, so what's Manning coefficient? Or what's the flow rate? Roughness of the surface, exactly. So if you remember from your hydraulics, your speed of flow, whether it's any liquid you spray or the runoff, you know, rain coming down. This rain pour, in order to drain it, you need to have a good drainage system. You have to study the inlets, the size of the inlets, whether you talk about a roadway or a bridge, and the spacing between the inlets, the piping. You have to do maintenance and clearing for the piping so you don't get any clogging. Also, you have to make sure that the water on the roadway have enough or easy path to the drain, Because if the drain is working fine, but there is heavy roughness on the surface or no slope on the surface, then basically you will end up with ponding or slow drainage, and the thicker the layer of water accumulating, that would result into hydroplaning. I'm not going to talk about splashing or ascetics, but I'm talking about hydroplaning, and I guess all of us know what hydroplaning is. You know, when you have a thick enough layer to make an insulation between your pavement or your roadway surface or the bridge deck surface and your car tires, then basically your brakes are not efficient. You can slide. It is like having black ice or snow on top. So pavement, you know, it's inversely proportional, the speed of the flow to Manning coefficient or the roughness coefficient of the surface. So the rougher the surface, the slower the speed of flow, the poorer your drainage, no matter how you invest on the drainage system or how good the design is or how good the maintenance is. So this is an important criteria we have to consider when we do our pavement. The drainage, not only the drains, not only the size of the inlet, not only the spacing of the inlet, not only the size of the pipe or clearing the inlet and the pipe, but also the pavement itself, whether the roughness or appropriate slope. Now, soft or flexible pavement, it gets its name from how it flex or bend under the loading. I'm not sure about traditional sections here, but it's in the neighborhood of 24-inch or 25-inch total section. I'm talking wearing plus whatever is below, sub-base and base. So we're talking about close to 50 centimeter for the two layers, sub-base and base, and then close 4 to 6 inches for the flexible pavement only, which is the wearing surface. That accounts to 10 to 15 centimeter, dependent on the importance of the highway and dependent also on the mechanistic empirical. You know, if I can make a regular or a general statement, the thicker you are, the better off you are. However, you don't need to overspend if you don't have enough traffic to deteriorate. Keep the money for a better or a different use. Percentage-wise, for the binder or the asphalt concrete, we're more or less ranging very least of a 4%. I would say it's not used anymore. The general average is 5-ish, between 5 and 6%. There are other types I will talk about tomorrow that last week, as I mentioned, when the bus took us to the CIA instead of the Turner Furbank, and then we corrected our way and we went to the Turner Furbank, I asked them to see all the advances. You know, one of the good things that I saw, they have multiple lanes. I don't remember how many. It's probably 11 lanes. And every lane has got 4 sections. So they have a total of 44 sections. Very short lanes, like probably it is the length of this hallway. That's a full lane. And they divide it into 4. And then they have 11 of them. So they have 44 different spots. Every spot, they can place different type of asphalt. Different wearing surface, different base, different sub-base, could be flexible, could be rigid, even concrete or roller compacted. And then they do have testing trucks. And they let it keep going back and forth so that they can estimate the impact of the mixed design and the section thickness and all the parameters, the gradation of the aggregates, the thickness of the sub-base. So they're doing weird stuff. I'll show 4 different sections that I just took a picture of from the heart of Turner Furbank last Friday, actually, right? A few hours before stepping into the airplane to come to Nigeria. One of the things they are trying to do, they call it the reverse asphalt. Like traditionally, if I told you here, which of these sections, like you see here, the top surface and the wearing surface, and then the base and sub-base, and then your subgrade. Let's skip the subgrade. Which of the top 3 is the harder or the better quality? Which one? The surface. Why? Remember the previous slide? Where is the load applied? Surface, right? Where is the least interaction? The smallest area? It is a surface. You know, as you go down I mean, don't look at the stress. The stress is opposite to the interaction area. Stress is force over area. The larger the area, the smaller the stress. So right at the point of intersection, the tangential point between your surface and your tire, it's almost the area of tangent. It's like that, right? And then after this, Director Emeritus is saying like this. Roughly, when I teach geotechnical courses, I tell my students for the ease of calculation, consider it 2 to 1. You go 1 horizontal to 2 vertical. It depends, of course, on the angle of repose or angle of rest or the, your sieve analysis results, how many or how much silt you have, how much clay you have. But anyway, a very good averaging is 1 horizontal, 2 vertical. That tells you that the deeper you go, the larger the area, the smaller the stress. So any smart engineer would like to invest, you'd invest on the top surface because it takes most of the heat, right? And that's what we are used to do. Right now, there is new trend to shift. They make it the reverse pavement or the reverse asphalt. I captured a couple pictures. I'll try, to add them, to one of the presentations tomorrow to show you what they are doing. But basically, they came up with the concept that the majority, especially in some states, the majority of the problem, it stems not from the surface, it stems from bottom-up rutting. And in America, rutting is a major problem because of the amount of traffic, because of how heavy the trucks and trailers are with all the cargo on them. Especially some corridors where the NAFTA agreement is the trade corridors between the US, Canada, and Mexico. So, the US is in the middle. So any trucks going up or down, north, south, it passes through some states. Michigan, sometimes Chicago. There's definitely, Kansas, Missouri, those in the middle. And then down there is New Mexico, there is Texas, there is Phoenix or Arizona. All these are touch points between US and Canada. So these highways, no matter how good you do the compaction, no matter how good you do flexible pavement, you're prone to bottom-up rotting. Then they just, okay, let's shift to rigid pavement. Good solution. But unfortunately, when you talk about Canada up north, there is a lot of cold weather. A couple slides ago, I mentioned that asphalt is good at frost heave or pressure from down up. So what are you going to do for the northern states? You put concrete to fight rotting, and you end up with problems because of frost heave. So they said, okay, then we need to combine a strong base and sub-base with a flexible surface. So from that point, they developed the reverse or the inverted. I think the terminology they used is inverted. I have to check it. It's kind of new, but I have how the section goes, I have it. So basically what they are doing is they are strengthening that base course, make it much stronger than the surface. Sometimes they add binder to this, believe it or not, mix it like FDR. But most of the time they do strong stabilization. And soil stabilization, it depends on the nature of the soil. If you have soil that tends to be sandy soil, what do you think you're going to do? They do cement-based stabilization. If it is silt and clay, they do lime stabilization. So you end up with your base course almost like a beam, as if you are having a layer of semi-rigid pavement, but it's not rigid. And on top of it is your flexible pavement. This way, when the load is transferred, this bottom one is super strong, so you're not afraid of the rotting. And the top one has the ability to, yes, flex. So this is one of the developments on the asphalt they are doing. Now, categories for rigid, I know you're not using it. I think the future will include, it's a newer trend. Like in Egypt, 10, 15 years, like when my dad was alive and he was undersecretary in the Ministry of Transport and Ministry of Housing, if you tell him concrete pavement is like, well, 1 in 1,000. Right now we're talking about 3-4% in Egypt, It's going up. There is the new capital built on the desert. There is a lot of these types of roads by the pyramids, between the pyramids and New Egyptian Museum. If anyone is following the news, they're having what they call tourism corridor or something like this, where they will have electric cars to take you between the pyramids and the new museum. It's about a 1.5 mile drive, and then there will be cable cars and electric cars. Anyway, it will be open sometime end of this year. So they had concrete there because based on like UNESCO, UNICEF, some of organizations, they wanted that area to not have a lot of dark colors, to look natural, close to the desert, and little pollution. So they found concrete to be a better option. So rigid pavement or PCC, Portland, again, remember, it's PCC or RCC. PCC, it is Portland cement concrete, and RCC is roller compacted concrete. The normal Portland cement concrete, we use it, as I said, almost 7%. Whether you use it as continuous or jointed or reinforced or non-reinforced. You can have multiple combinations. Reinforcement and joints, reinforcement and no joints, plain or no reinforcement and joints, plain and no joints, but this is very rare because if no joints, you need to have reinforcement to manage the cracking because of expansion and contraction. And then there are some pre-stressing, but I really don't see it much, where you use precast, pre-stressed slabs. Now to RCC, and I need you to pay some attention. I know it's hard because it's the end of the day, but it is the new kid on the block right now. It is being used extensively in applications where you are afraid of rotting, or where you basically want to cut down rebars, or where you have extensive loading, like in, or impacts, like, airports, they use it. Harbors where you have lots of freight and lots of containers and heavy loading, or heavy places of industrial parks or things like that, and some highways for sure. So RCC, in general, it's concrete at the end of the day. We know what concrete is made of. You have some voids, some water mixed with cement that gives you the binder, plus a content of the aggregate to fill the voids on an economic basis. Aggregate, some of it is coarse, some of it is fine. So water, cement gives the strength, voids coarse, aggregates coarse and fine as a filler, and some voids, right? This is regular concrete. Same. Nothing is different. Contents are the same. Proportions are different. And when you do the placement, it is not like concrete. You don't get it offshoot or pumping it. You place it. I'll show a video, hopefully work, at the very last slide, a few-minute video, talking about how, to manufacture, the advantages, the disadvantages. Very nice video. So what is the difference in constituents? Whoops, what is this? Okay, I'll talk about, RCC. I kind of, my line of thinking get a little bit faster. So RCC, I'll have a nice presentation, nice slides at the end after I will talk about the flexible. So sorry, I got distracted for a second. So, there are asphalt, like the asphalt cement, or, the cutbacks or emulsions. These are all natural, and then there are, the tar. Now, asphalt cement or binder, we have, as I mentioned, HMA and the patching. We have cold mix, which is only for maintenance. We have warm mix as well. There are, if you talk about tar, I don't think you'll use tar in Nigeria, right? It's... You do? It's on the decline in the US. Everything is petroleum based. Yeah, so I'm making here some comparison just to show you the differences in the water resistance and adhesion and set time, etc. So these are major, characteristics or properties for asphalt cement. Again, emulsions, and tomorrow we will talk in details about emulsions, because when we have our preservation methodologies, or how to maintain or preserve our bridge network. There is a lot of use for emulsions in lots of topical or spray preservations. I will have a detailed slides about it tomorrow. Now, yeah, coming to the rigid pavement, that's where I was mostly focused on. This is similar type of section, sub-base, base, and concrete pavement. And our rigid pavement, as I said, you can have, have it used because of the durability, availability of contents, ease of construction. It's very good with rain. Rigid pavement, these are the options for it. The JCP, plain and jointed. Plain means no rebars, and jointed with joints. Jointed, reinforced. So you have rebars and reinforced. Continuously reinforced, so no joints, but you have reinforcement, just to take care of expansion and contraction, so cracking because of climate change. Then PCP, the pre-stressed, I honestly haven't seen it. Now, some attention here, please. The rigid pavement or the roller compacted concrete, this is exactly as you see it. Can you tell me some differences here? Huh? What about slump? No slump. You see it standing, this is fresh. This is not hardened. This is fresh. Zero slump. It's literally like you're placing a piece of rock. You don't have this collapse unless you have really high height, so its own weight. But if you have like 10, 12 inches, zero slump, zero sliding, zero everything. So you don't need to have side forms. That's one major advantage. It's ease of construction. I'll tell you the story about fighting, cost fight, but then you see the surface is rough. So some people put a thin layer of asphalt or fog seal it, or they might even do grinding for the surface. And the reason is, if you do rigid pavement in major highways like interstates or freeways, drivers complain because of the roughness. It's high noise, they're not very comfortable. Also, they're afraid of the depreciation of tires, right? Now, if you do it in residential area, people who are walking with canes and skateboarders and those people, they'll tell you, oh, we're gonna fall. We're going to sue you. You will break our arm. You will break our leg. So this is, that may, and you cannot have a very fair surface like like PCC per se, because of, it's very rigid. Even if you roll it, we'll see how it rolls. You place it by pavers, asphalt paver. You do very heavy like surfacing, but still it will end up rough. So that is the previous slide that I was talking about. Yeah, oops. Here is the differences. The bottom one is your R roller compacted, and the top one is the conventional. As you see, same ingredients, no big differences. However, the percentage of voids is getting close to zero, and you use higher percentage of fine ingredients, fine sand. Water cement ratio is a bit less because you're having very low slump, or zero slump actually. The funny thing, the US Corps of Engineers, the one that does all the construction for the Army, they call it negative slump concrete. So if you ever did, like I've done a few projects with the US Army, even before immigrating, like I was graduating during the second Gulf War, Iraq and Kuwait, and the American Army was there in the area, so they used all Egyptian companies, joint venture with US companies, to make all the construction on the Gulf, residential airports, So I was one of those engineers deployed to help them. So they used it a negative slump. It's like, what negative? You put it, it goes up? No, it's like a term for zero slump concrete. So the mixed design approach, it is volumetric method like ACI. You have a phase diagram, you add all the constituents or the ingredients to a 1 unit volume, 1 cubic yard in the US, 1 cubic meter here. However, the approach in proportioning the constituents is different. Does this remind you of something that Dr. Patrick was talking about yesterday? The 0.45 power chart. It is actually a chart developed by the FHWA, Federal Highway Administration. The whole story behind this is, if you do a regular sieve analysis, you can tell what gradation you would have for the as-is aggregates or as-is soil, right? You can tell the percentage of coarse, the percentage of fine, the percentage of every size within the coarse with, stuff like that. But if I give you 3-4 different aggregates with 3-4 different gradation and 3-4 nominal maximum sizes, and I told you I need you to combine them together, what proportion would you take from every one so that the overall mix of the aggregates only would have the least amount of voids? Is this clear, that question? So basically, you have aggregate A, aggregate B, aggregate C, aggregate D. All of them are different in nominal maximum size, the size through which, the least sieve size that passes 85 or 90% plus. That is as what Dr. Patrick said yesterday, and that's 100% true. In the US, sometimes we say 85%. Passes, it makes it the nominal maximum size. But anyway, this nominal maximum size and this gradation are different for the 4. Now, should I take 25% of each and add them to make 100%? Or should I add 20, 30, 35, and 15? Or should I add 20, 20, 20? That's 60, then 40. So anyway, you have to take some, add them together, that is the 100%. Now, which sum you take to have the best packing order? The best packing order means the least void percentage. Now, this is used in many applications. One of them is the UHPC, which, ultra high performance concrete, which is in Europe, they call it reactive powder concrete. I've seen here a truck with the word Lafarge on it. So basically you have Lafarge company working here in Nigeria. So this Lafarge, they developed the UHPC. One of the approaches to enhance the strength is to cut down the voids. You have to cut down the water because it negatively impacts the strength. You have to cut down the voids, right? So cutting the voids, they developed this. Then the RCC people, they said, hey, okay, we're game with you. You cut down the voids for higher strengths on the UHPC. We want the least voids for RCC. So we're not going to use traditional sieve analysis. We're not going to use regular traditional methodologies for proportioning our aggregates. We're going to use this type. I'm not going to repeat much, but again, you go from here, the smaller to the larger, the straight line, the black line, it's a fresh reminder, revision of yesterday. It goes from 0, the point of origin, all the way up to the nominal maximum size. Some people consider it maximum size. There is a debate, but the difference is not big. It's only one sieve size. So you draw this black line, and this line, you are targeting your mix from aggregate A, B, C, and D with different proportions. When you make this mix and you do sieve analysis for it, the curve you have become as close as possible to this line. The closer you are, the lower the amount of voids. Presumably, if you can hit the line, you have 0 voids. Nothing like that, it's theoretical, but this is presumably what you have. So this is the first difference in RCC. You don't use the regular charts. I mean, we use the regular volumetric mix design, but we don't use the ACI charts. We're using the FHWA 0.45 power chart for proportioning different sizes of aggregates with different maximum sizes to cut down the voids. Does this remind you of something? What is this one? Yeah, it's basically optimum moisture content. For those of you doing research in geotechnical, yeah, guys, I'm giving you a hard time now. Talking materials, talking asphalt, talking soils, hydraulics, Manning equation, but it's good to have all this packed together. So remember, in geotechnical, what we used to say, if you have very low moisture, then when you do compaction, you will not have high efficiency because your solid particles are rubbing against each other. So efficiency will go down, that means density would go down, that means your voids will go up. This is under low, very low moisture content. You keep increasing, the water serves as a lubricant. It expedites or facilitates compaction. So you end up with better compaction, your density go up, that means your voids go down, right? Until a given point after which you'll start to curve down again because water, remember, it lubricates, but it is a buoyant. There is buoyancy. So it will resist the compaction, make it go back to the negative. So basically, that is the curve we use for moisture content before doing compaction for our subgrade, before pavement per se. We use the same, but now for a different thing. You do multiple mixed designs with multiple water cement ratio. Remember, this is a new kid on the block. So there is no specific standards, unified code like ACI or ASHTO that tells you 1, 2, 3. So there is still ongoing research. Yes, sir. Uh-huh. No, I mean, can you raise your voice?
The 0.45 bar charts for the sieve analysis. Is it at a 45-degree angle?
No. Okay. Why? Okay. Good point. Let me go back. Oops. Very good question. Okay. What is the vertical coordinate here? It is percentage passing, right? Yeah. What is the horizontal coordinate? Sieve size. This is for normal sieves. Here, you make the sieve size raised to the power 0.45. That is why we call it 0.45 power chart. Yeah, I don't think even Patrick mentioned this yesterday, because we take it for granted that it is something known, so we forget to mention. But yeah, it is the x coordinate is the sieve size in millimeter raised to the power 0.45. Vertical coordinate is the percentage passing. So once here, you use the 0.45 power chart to determine what exact proportions of your multiple aggregates that you need to make so that you have the least amount of voids. Then you use the optimum moisture content curve, or you can call it optimum moisture content based on geotechnical analysis to come up with the water cement ratio. And usually for RCC, it will be very low. You don't see numbers like 0.45, no, or 0.5. Sometimes it go down to 0.15 or even 0.12, 0.13. Remember, you have a zero slump. Then the last thing is we got the water cement ratio, but how much water, how much cement? You can have different cement and different water and the ratio is still constant, right? So knowing the ratio is one thing, but knowing the amount is something else. This is how you do the amount, is empirical, like the mechanistic empirical. You do multiple mixes, you have the aggregate combination, you have the water cement, then you make an assumption for a cement content, and based on the water cement, you calculate the water. After knowing the cement size, the water size, the rest is filled with aggregate, right? Then do the mix, compression test, regular compression test, cylinder, if you use cylinders, cubes, I think here you use like 16 or 15 centimeter cube. 15. Yeah, it's like Egypt. We use, when I grew up, we were doing 15.8, exactly. Cube 15.8. In America, it's either 6 by 12, 6 inch by 12. That's 6 inch diameter cylinder, 12 inch deep. That is the largest. Then because of the stresses are going high, a couple times during my PhD, I broke the machine before breaking the cylinder because some of my work was UHPC. So I had concrete at some point as high as 200 MPa. So machine was not designed for this. So you hear a break, and then, you know, my advisor come, did you break the cylinder? No, I broke the machine. So, so he said, okay, you're costing me $10,000 machine because of your PhD. You know, I was like, you want to produce your HPC? I should get the PhD now, right? I'm successful. So that's why they standardized, instead of 6x12s, they made the 4x8. Right? When you shrink the area, the total force is low, right? For the same stress, because stress, again, the total force is stressed by area. The stress is constant. The smaller the area, the smaller the total force. So machine can be safe. Now with Lafarge, they are standardizing 3x6. So it's even much smaller because they're hitting close to 300 MPa compressive strength. So you do multiple cylinders or multiple cubes with different cement content, which would result into different water content, and the aggregate you proportioned, and you break. Now, you know what exactly is the strength, so this is trial and error. You draw the chart, that's regression, right? And then you come up with the strength horizontally, you hit it, you go down, that tells you what exactly is the cement content. Now you brought the cement content, and here you know water cement ratio, so knowing the ratio and knowing the cement content, you can get the water content. Calculating the water volume and the cement volume, you will know the aggregate volume, and through this you know the aggregate percentages, so you can mix the percentages with quantities that give you the volume, and then you work it backward, and here you go. Advantage-wise, and I promise I'm going to be almost done. You know, heavy-duty application loves RCC. Talking about ports, airports, talking about military. The military is high. That's why the U.S. Corps, they are standardizing this in a lot of projects. Dams, because you need a watertight, if you do concrete dam. Roadway applications, it is there. Even in, you know, arterials, city streets. Then in light commercial and industrial, it is also there. Now, to be fair, I have to, yeah, this is the advantages. Again, it gives you faster pavement because, you know, once you place, you roll with pavers. You don't need any forms. You don't need reinforcement. The reason of no reinforcement is the higher percentage of the fine aggregate. And usually the expansion and contraction happens because of coarse, not fine aggregate. So if you lower the percentage of coarse aggregate and you lower the size of the coarse aggregate to improve the packing order, then there is no need for reinforcement. Why would I waste time and money, right? Finishing is little with the exception of surface grinder, labor saving, you're using machinery. It's safe because while pouring you have better visibility, you have less fumes and vapors, you don't use, not like hot mix asphalt, 150 degrees. Very sustainable, low energy consumption. Just to be fair, I have to mention some about the impediments, you know, because sometimes it's too good to be true. Think about the surface. As I said, it's a rough surface, so you have to do surface grinding. A lot of truck mixers, I mentioned this either yesterday or the day before, because of zero slump, if you fill the truck like you do with regular PCC, by the time you start pouring it, it will already harden on the mixer. So you have to use very little amount, half or even 1/3 of what you do with regular PCC. That makes you use more trucks that increase the cost. Edges sometimes are hard to compact. You have to have rapid placement because of very fast setting. It's already dry. So if you are pouring a long segment and you delay the pour, you'll easily have a cold joint, which is usually a weak point. Hot weather like here could probably be hard. I mean, we have faced during my father's time the same hardness building the high dam in Egypt during President Gamal Abdel Nasser time. So the amount of water they used to weigh ice. So half the water was ice weight. They place with the mix. Or you can use plasticizers, but that will shoot the cost high, which is the last point. Just to conclude, there is a few minutes video. I'm not sure why the link is not popping, but guys, at the end, you have internet connection. If you can take a cut paste of this link at the very bottom of the slide and put it on Google search or whatever, that will pop a video, a few minutes video. It's very, very informative video about roller compacted concrete. Yes. Yeah. Yeah, if you can bring it back and make the sound, please, or volume. Yeah. And then the volume. Can you fix the volume? Is from down there, the very bottom left, or I don't know. Yeah, I hope we can fix the problem, because tomorrow there is a lot of short videos for different methods for preservation, so its volume is crucial. Yeah. شوف عندي. Yeah, see the computer, not the video volume, the computer volume itself, is it muted? You know, if it is not working, can you Google or can you go to YouTube and write the word roller compacted concrete? Maybe you can pull it directly from the internet. I'm not sure if that will make any difference, but it may fix.
Consists of four main ingredients: water, cement, sand, and rock, which are called fine and coarse aggregates.
Perfect.
Concrete is widely used for roadway paving all around the world.
Yeah, we
But
fixed the
can you
sound.
pour
Now we need
concrete
the...
pavement with no rebars, formwork, and expansion joints?
Excellent.
Traditional answer would be no. But what if I told you that you can and
Can we
that
bring it
would
back
not be
to
sloppy
here,
do
to
it
the very
yourself
beginning?
project? But concrete is widely used for roadway paving all around the world. But can you pour a concrete pavement with no rebars, formwork, and expansion joints? Traditional answer would be no. But what if I told you that you can and that would not be a sloppy do-it-yourself project? Rather, it would be an industrial-grade concrete that is capable of withstanding tremendous pressure and heavy loads. Today, we will talk about a very special type of concrete, a type that most people never heard of. Concrete that does not look like traditional concrete, and that is not even placed like traditional concrete. Yet, it is much more durable and robust than traditional concrete. It is called roller compacted concrete, or simply RCC. Today, I will explain to you what RCC is, how it differs from traditional concrete, and we will look at the placement process and its history. So, what is roller compacted concrete, and why is it so different from traditional concrete? For us to answer this question, we need to understand what the fundamental difference between traditional concrete and RCC is. Let us look at how traditional concrete is mixed. Concrete consists of four main ingredients: water, cement, sand, and rock, which are called fine and coarse aggregates. To get a concrete, those four ingredients are mixed in proportions. Typical rule of thumb is to use 1:3 ratio, which means for 1 unit of cement, 2 units of sand and 3 units of rock are added. Water is added into the mix by eye judging to get a desired consistency. Within the industry, things are not that simple, and concrete mixes are designed by the engineers. Batch plants very carefully measure and weight each component, including water, prior to mixing. However, at the end of the day, it does not change the outcome. As a final product, concrete looks like jelly and flows very well. How does RCC differ from traditional concrete? RCC has two significant differences from concrete. First, there are no large rocks in the mix. Rocks are added to the mix. However, pieces of rocks that are used are relatively fine. The second difference is water. RCC has almost no water in the mix, and final mix has no viscosity, which means concrete does not flow at all. As a final product, RCC looks like wet sand. Such a different consistency of RCC material requires a completely different placement method. Roller compacted concrete is mixed by a mobile plant that is deployed right at the job site. Since RCC has no viscosity, it is not transported in traditional concrete mixers. Instead, RCC is transported in dump trucks.
This last statement, some people
Placement of
mix it
RCC
on the
is
mix.
usually done in
It's not
two layers,
100%.
which are called bottom and top lift. Lifts are placed by pavers that look like a typical asphalt pavers. This whole process sort of looks like asphalt placement, however those pavers are not that simple. Pavers are equipped with special tampers that compact RCC to at least 90% of its density right at the placement. Leading paver places bottom layer of the RCC. Paver receives concrete directly from dump trucks that dumps RCC into paver's hopper. Heavy roller follows leading paver. Its purpose is to further compact RCC to 100% of its density. This is where the name comes from. As concrete is placed, it is compacted by rollers, so it is called roller compacted concrete. The second paver follows about 100 feet behind and places the second lift on the top of the first lift. Since RCC has no viscosity and it is compacted to 100% of its density, equipment can walk on RCC's surface right after placement with no issues. Unlike traditional concrete that stays liquid and then soft for an extended duration of time. The second paver cannot receive concrete from dump trucks since it is blocked by the leading paver, so instead RCC is moved into its hopper by a conveyor. Entire pavement range slowly moves together as RCC is being placed. If RCC is placed in one lift, it just makes operation much simpler. In some cases, when the finish needs to be smooth, a troller can be utilized, but it does not happen often. Finally, a bobcat usually runs around, picking up RCC that was dropped by trucks or conveyor feeder. Urine compound is sprayed on the surface of the top lift after roller finishes compaction. It prevents evaporation of water from concrete. Pavers are guided by lasers along pre-established lane line. Placed material is frequently tested to verify its density and moisture content. The RCC paving process is extremely quick and efficient. In one day, pavers can easily place 1200 foot of 18-inch deep and 30-foot wide lane, which is an insane production rate. Even though RCC can withstand significant loads, it does require extensive preparation of the subgrade. However, it is fair to note that subgrade preparation is the same for both RCC and traditional heavy-duty concrete. The bottom line is simple: subgrade needs to be able to carry design load, and it doesn't matter what concrete is used on top of it. I have a separate detailed video of how subgrade is prepared for placement of 18-inch thick concrete for the container yard. Check it out if you don't know how subgrade is prepared. Link is in description. Let us quickly look at the cross-sectional drawing of the subgrade. At the very bottom we have 8 inches of lime cement treated soil. On the top of it we have a geotech style layer, and then 4 inches
These
of drainage.
are recommendations.
Next
Geotech
is 12
style,
inches
but you
of
can do
cement
it
treated
without geotech
base,
style.
to follow a bond breaker, and 18 inches of concrete, which is placed in 2 layers of 9 inches. As subgrade is prepared, a traditional concrete requires installation of the formwork, reinforcement and joints, none of which are required for RCC. This is a huge game changer, since such preparation is expensive and labor-intensive. Cutting formwork, reinforcement and joints out of the equation saves huge amount of budget and significantly increases placement rate. So why all that is unnecessary for RCC? The main objective of the formwork is to keep concrete from floating away, since its natural form is jelly and it flows well. As we know, RCC has no viscosity. As a result, formwork is not needed. The main objective of reinforcement in pavement is to control cracks. Cracks appear in a concrete during its shrinkage, as it dries and cures and changes its volume. But RCC is compacted to 100% of its density and has very low water content. So it does not really shrink and does not form excessive cracks. Hence, unlike traditional concrete, reinforcement is not needed. It would be fair to note that RCC does form minor cracks, but those cracks do not present any danger to its integrity. The main objective of the expansion joints is to allow concrete to move as it changes its volume during ambient temperature change. However, such volume change occurs primarily due to the rock that changes its volume in the body of the concrete. RCC does not have large rocks in its body and almost changes no volume with ambient temperature change, so expansion joints are not needed for RCC. Besides those benefits, RCC also offers several other benefits. Very high compressive strength, excellent load transfer over cracks or cold joint lines, almost immediate readiness for the traffic, and finally, RCC performs extremely well under freezing conditions. So where does RCC come from? The first experiments with concrete were conducted in the early 1930s, when engineers started utilizing concrete for pavement and roadway construction. At that time, pavement operations with concrete were expensive and time-consuming, so the goal of the experiments was to find more economical mix and to decrease placement time. But there is not much information about early research, and applications of the RCC were very scattered. RCC got real traction in 1970s, when Canadian logging companies started widely utilizing RCC to pave their laydown areas, where logs were stored. RCC turned out to be much cheaper, ignorant to frost conditions, and extremely fast in placement. After such success, American Corps of Engineers started its own research of relatively new technology, and conducted experiments and studies in 1980s
Corps of Engineers is the
and
Army
1990s.
engineers. They use the word Corps of
In the early
Engineers.
2000s, RCC applications and usage started growing drastically, and today it is a very common go-to material for heavy-duty applications, such as container yards, busy highways, airport runways, and storage areas. Another side application that was found for RCC is dam construction. There are quite a few dams all around the world that are being built with RCC, and dam construction exploded in the early 2000s. New RCC dams are being constructed all over the world. If you like construction and engineering how-to videos, don't forget to hit like and subscribe buttons.
Okay, so you can stop now, the video is over. So one thing I need to mention before we end this presentation, that contractors hate RCC because they lose their equipment much faster. You know, it's a heavy material, so once you use your roller, it really depreciates fast. So if you get a pushback, like, it's all advantageous for us as highway engineers. It's advantageous for the country. It is advantageous for the long term. But some contractors tell you we're losing the equipment. Also, it doesn't need a lot of maintenance, so they lose the money they will make out of maintenance down the road. So, you know, they don't want to sell you a very reliable product. I'm serious, that's how they look at it. It might make some of them out of business because, especially for those who are living or making a living out of the maintenance of the highways, it dramatically impacts their business. Earlier, or my research, I mean, if you Google my name, just my name on Google, you will find one of the publications. It's a very recent, like last year. It is the specifications of RCC for the state of North Carolina. I developed it for the Department of Transportation through my research at the university. You'll find all the information, including the negative sides. I have to be honest in my research, put the plus and the minus. Regardless, they like it, they don't like it, that's my duty as a researcher. So I have also to tell, initial cost could be like a 130%, like 30% more, 25-30% more, but it pays it back to you because of the very low maintenance, if you think about life cycle cost. So initial cost will be higher. Contractors doesn't like it because of higher depreciation, but once you get it done, much lower maintenance, much lower preservation. I mean, it is a good product, especially with heavy traffic, or if you need rigid pavement because of soil condition, or you need, sometimes it's fast in production, so airports, they use it as well. And environmentally, it's good. Even if you use cement, which is not good, but it's not much high, and you don't have any heat, or literally any heat, like the hot mix asphalt, no vapors, no fumes. It's healthy for laborers. Okay, that concludes our RCC. Whether you have any questions about this presentation or anything about the whole day, including AI, MEPDG, this one, I'm here. We still have a couple hours, right? Engineer Isa. Any questions?
Prof,
Yes, sir.
Thank you very much for the presentation.
No problem.
So, usually the M&G department and designers here in Nigeria, we actually carry out CBRA tests. We don't estimate them. That is the actual truth. But I noticed that I wanted to find out what are the control tests that you carry out before laying the RCC. And then I also noticed that the base before the RCC, that is the surface before the RCC, it seemed as if it was asphalt or something. I don't know what material was that. As if it was already prepared, as if it's laid on top of it, I don't know.
Well, okay. To address your questions, whatever you do for regular concrete, you do for RCC, because the load once transferred to the soil, it is the same, right? So any test you want, again, there are no specific standards, but any general intuitive thinking, whatever you do for rigid pavement or even flexible pavement, there is nothing wrong. Go ahead and do it for the geotechnical. You want to say CBR, you want to do anything, compaction, whatever, go ahead and do it. Proctors, you name it, any testing. To answer the second question, I don't remember what you were talking about, but most likely you're referring to a geotextile. So in this video, and I intervened immediately, I think that's when I stepped in through the mic. in the US, there is a higher trend of using geotextiles. Do you know what geotextiles are? Yes. Yeah, they basically use it whether on the subgrade or between layers. And the reason for this, as I mentioned in the, earlier, the higher levels or higher strata has a better qualities than the lower ones, right? So they figured out with research that with time, under the pressure of the trucks, layers starts to get mixed. So the strong top one get mixed with the poor below one. So it loses its strength. So they lay this geotextile as a separation. So the top layer with top quality that you spend a lot of money for, when you press on it, the good particles, the expensive particles, does not drop down through the poor ones. So more than likely, that is what you saw. It is, you know, it is like sheets that you lay. It looks like asphalt. If you take a snapshot or you capture it with a drone, geotextile, you know, not all of them, but some of them exactly look like asphalt. From far, you think they're laying asphalt. But it is a geotextile for soil enhancement. That's very good. 2 questions, actually. Yes, sir.
Thank you. This
My
was
pleasure.
very insightful. First is to confirm that when you lay the RCC, you compact, right? Okay, then based on that, in the applications, you mentioned that for heavy-duty operations, it is applied. And then you mentioned for dam construction. So I wanted to find out how the compaction is done for when the dam construction is being carried out.
It's like you put layers, and every layer has to be compacted at its own. Now, the thickness of the layer, it's a trial and error. There are no specs for this. Is this what you're asking for? Yeah, you put layers. How thick the layer is, it's like, you know, geotextiles. You know, I read a lot about this research. I use them in a couple projects in the industry. But some people tells you if you have a thicker embankment, like let's say you're having 2 levels of a highway and then there is a slope, how many layers of geotextiles you put to support the top one, if you're not using a retaining wall per se. Some people tells you do for the top 6 feet. Some people tell you, no, you have to go all the way. And if you go all the way, should you go with a 2 feet spacing, 3 feet spacing? You know, depends on the manufacturer different manufacturers have different specs, depends on the material, depends on the soil, you know, depends on the bearing capacity. And, you know, some manufacturers, they tell you, well, I mean, it's enough to put the top 2 or 3 or 4 feet or go all the way. So same for roller compacted. If you have like a massive lay of concrete, split it into layers, roll it, but the problem here would be you have to watch for joints, cold joints. So you better do it fast. Like, I mean, in normal concrete, we specify 45 minutes. There is no specs as of this minute that tells you that's the maximum time. You know, 45 minutes, that's why, you know, most of the specs, global-wise, on a global level, they tell you the initial setting should not be less than 45 minutes, right? That, I assume that's what you do here in Kenya. So that's what we use in Egypt, that's what we do in America. So RCC, no specs. So it is, you're running a little risk. And that's, by the way, part of the reason, even not contractors, some DOTs, the engineer don't want to take the risk and be a supervisor of an RCC concrete and he doesn't have, you know, solid specs. They are afraid of being called bad engineers or they had site problems. This is part of the pushback. Yes, sir.
Thank you, Prof. I'm just wondering the cement quantities between PCC and RCC, which one consumes more cement? And again, what tests do you run to make sure that the compaction is 100% of RCC at points at which you are laying it? Thank you. What test
you mean okay,
Test,
good. Let us agree on a couple things. One, water cement ratio is less, right? But also the amount of water is less. So the percentage of cement is not much different. I mean, there is, I can say most of the project, you cut it a little bit, but some of the project, this difference between the cement of conventional concrete and roller compacted concrete, they add fly ash. I'm not sure if you know fly ash, Class C fly ash. And the reason for this is fly ash is extremely fine, so it fills the void even between the sand. So it adds up to the higher packing order and the reduced voids. So to answer, again, there is not a very sharp answer, but I would say they are comparable, and if you go below, most likely you will compensate the difference with some supplementary cementitious material, pozzolanic material, or Class C fly ash, which is the cheapest. I'm not sure about the cost, like when I said this in Dubai and Saudi Arabia, it's like, wow, fly ash is cheaper, how come? Well, in America, the ton of Portland is about $100, $110. Ton is US ton, so it is 2,000 pounds, which is 900 kilograms. America's ton is different than our ton. So 900 kilograms is about $100, $110, maybe 120 now. Portland cement. Fly ash is $15. So there is a massive saving. So that basically covered the difference. Now, what is the other question? What test? It's a regular Proctor's test, like soil mechanics. So when you say 100%, it is basically having 0 voids. You know, when you have, you know, remember how you calculate for soil when you do gamma dry and gamma solid? So that's the exact thing. You do Proctor's or modified Proctor. You have the Proctor's mold, and then you split on 5 layers, 25 times compaction, and then you do the density test. And that will keep going up until it starts to go down. And then basically, this is your 100%. 100%, it doesn't make it like 0 voids. It's 100% the maximum compactability given the Proctor's value. This is what we do. So it's a normal soil mechanics test. As I said, it's a new kid. So maybe in 5-10 years, these would be changed. But as of now, we proportion aggregates with 0.45 power chart, which is used by UHPC, ultra high performance concrete. We get the water cement ratio by Proctor's test, which is used in the geotechnical world. So we are borrowing from left and right, put together some standards which would allow the contractors to do at least a better job than leaving them at trial and error only. Any more questions? Yes, sir.
Thank you once again, Prof. My question will not be on the RCC, but basically on the material. You mentioned something, as much as possible, I have been trying to relate this program to our peculiarity in Nigeria as much as possible, which I believe will give us more understanding and in-depth research. I mean, considering the research facility available to us in the country.
Excellent.
Now, you mentioned something, although you've answered, so you answered part of my question when I was going to ask about the specs. So I won't ask about the specs for the RCC. But when you say poor geotechnical materials, is that the main reason why you want to, let me say, promote RCC, or basically what you have in based on your experience? Because if we were to look at this part of the world, we have about 3 different type of areas. In the north, we have some places that they have good CBR that you might not, you can do your flexible depending on your traffic. And there's some part that you have very bad soils that you have, they are subgrade 10%, which you might want to look at. But when you look at the cost and you do your cost benefit analysis, you might not be tempted to look at into using RCC. So my question basically is, what do you define as a poor geotechnical material based on RCC?
That's very subjective. Again, there is no specs. However, any soil which will not fit for flexible pavement or calls for the use of rigid pavement, even PCC, is considered a poor geotechnical. Does this answer your question? So it's not poor or not poor if you compare PCC and RCC. No, I'm talking about 2 different animals now. If you talk flexible, and this flexible pavement, of course, given the size of traffic and the heavy loads, you will have problems if you use flexible, and then you will decide going to rigid, then this is poor geotechnical condition. Now, if you go to rigid, which way you go, Portland cement or RCC, that basically depend on your vision. Are you willing to spend a little more, not a little, 25% more, and save down the road and maintenance? Remember what we talked about on the asset management system? Spend more early, but save much at the end. Or maybe I'll use lower budget because I have lots of places else to spend my money in. So that's your own vision. You see what I'm saying? But poor versus not poor, not a cutoff number. It is flexible, regular flexible versus regular rigid.
Prof, well done for the wonderful presentation.
Thank you.
From the footage that we just watched now, and during your lecture, you read mention of, like, during concrete, you talk of zero slump.
Yes.
Now, zero slump, what about the workability? Like in Nigerian context, we discover that you have a paver there in your own way that is systematically moving the concrete uniformly. Some of the contractors that we have here, you discover that some of the pavers that they are using is not strong to drag this concrete. On the course of the process of laying, and peradventure, a reasonable distance has been laid, and it started raining, and it poured on the concrete. What are the remedies that one should carry in order to attack the excess water that is coming upon? And my second question is, concrete pavement, sir. What are the factors that makes this road to be constructed with a concrete pavement instead of the flexible pavement? Thank you, sir.
Okay, thank you so much. I hope I'll remember this. But you're asking about contractors not being able to pour regular concrete with some workability, so how would they behave if it is zero workability or zero slump? That was your first question. Well, there is no manual thing here. Manual, your hands are, as you have seen in the footage, everything is mechanical. And when it comes to compaction, you are using the same way you compact asphalt. That's why it's a roller compacted. You're not using regular vibration, you're not using manual vibration. It is all by heavy drum or roller compactors. So this problem doesn't come, if you don't have the right machinery, then the hands off, don't do it. But if you have the right machinery, then the question is already taken care of, or this concern is taken care of, right? Now the second one, what type of, or what are the conditions for, well, technically speaking, concrete would have lower maintenance. Now, whether that is right or wrong, there is a lot of research, and that kind of changes, and there is a lot of politics, there is a lot of opinions here, but overall, if you don't have frost and heave, which obviously not going to be in Nigeria, like if you have frost problem, avoid concrete altogether, right? If you don't have the frost problem, then if you have very good geotechnical condition, maybe you still can get away with asphalt. But if your geotechnical conditions are not good, so if you use asphalt and you don't do proper compaction or proper replacement and compaction, then you would have a lot of bottom-up rotting. Then you have one of two options. Either do soil replacement, which is extremely expensive, and then a lot of compaction, or just do your grading and regular normal compaction and shift to rigid concrete. As you have seen, the diagram for spreading the stress is way better. So it is the traffic level, or the correlation between the traffic level and the geotechnical condition. That relation would tell you. Now, the other option, and I think the point was raised from one of the engineers here, what if I want to cut down the thickness of the sub-base and base? This again calls for rigid, because the lower the thickness, you're now double shooting yourself. Flexible pavement means you have higher concentration. Lower thickness of sub-base and base means your subgrade is destroyed. So sometimes if you want to skip using thicker sub-base and base, it's better also to use rigid pavement, not flexible pavement. Again, you have to consider it's a case by case. So you have to do your own analysis. It's not like one size fits all. I cannot come with a formula. I cannot come up with a formula. No one has a formula that tells you once you hit this number, go this way. No, that's non-existent. Also depend on the expertise. You know, like FDR, I believe in FDR in preservation. I mentioned this in Dubai, they said no. We know it's good, but it's only one contractor in the whole Dubai that have the equipment for FDR. So he monopolizes. He shoots the price through the roof. They said maybe when we have open market and competition, we believe in the technology, but because of the lack of expertise, we're trying to avoid it as much as we can.
And economics. It's all about engineering and economics. Whenever you find yourself in a situation, look at engineering and economics, and you are good to go. Please, let us say something.
Well, it would be improper for me not to actually speak, even though you did not tell me I was going to do that. But, Mr. Speaker, let me join everybody in actually celebrating you for this wonderful conversation we have had this evening. I am totally enriched, even though I came late. However, particularly, I find myself in an environment in which, as we discuss engineering, and we are looking at sustainability, resilience and sustainability, how do we cultivate the platforms that will enable all of us to be able to practice all that we're learning here? Because if we learn some of these things and we are not able to be allowed to practice them, then it becomes a complete waste, a complete charade, as it were. And so I am hoping that, I'm sure that my friend, what he's talking about is to bring together the nexus between policy development and obviously the practice of engineering. And I hope that, I believe that this is what he's alluding to, because if we finish some of these wonderful ideas, roller compacted concrete as against concrete, can we deploy it? Can we be allowed to deploy them? And I think that that's a very fundamental question that we need to grapple with, particularly in working out the uniqueness of the country in which we find ourselves. Thank you, Mr.
All right. By your clapping, we shall know if we appreciate the lectures and teachings of Dr. Amin Aknok. Wow, that's a very wonderful one. So at a point, I was like, oh, I should have studied civil engineering or something. But I'm an electrical engineer, no problem. And as a project manager, I just got, very wonderful insights into addressing issues when it comes to, when you have projects like this, you now know how to think ask questions, you know where the pointers are. Ladies and gentlemen, we appreciate you for your time, and we want to recognize in our midst, you already heard his voice already, but then to know him better, he is a member of the Board of Trustees of the Nigerian Institution of Highways and Transportation Engineers. Please put your hands together as we welcome Engineer Chris Okoye, FNSE NIHTE. A round of applause for him. You are very, very much welcome. So, pardon. Oh, fellow of the Academy of Engineering. A round of applause for him once more. Thank you. So, ladies and gentlemen, I'll just quickly do a recap of what we have done today, tell you what we will be doing tomorrow, and then invite our training coordinator, Engineer Issa Moabinu, to come and have a word with us, and then we pray and we call it a day. So today, the first lecture we started at 9 a.m. Tomorrow we are beginning at 9 a.m. We had introduction to artificial intelligence for road asset management. You would all agree with me that we enjoyed it. And then asset management, and then introduction to mechanistic empirical pavement design guide and its role in enhancement of road sustainability. That was the second training we had. Then the third one was asset management systems. We looked at pavement management systems, and then we concluded with development of highway materials for enhanced roadway sustainability. We had coffee, tea break, and we had lunch, and you want to agree with me that it was good. So tomorrow we begin, we have the following trainings: techniques for enhanced roadway resilience, preservation techniques for enhanced sustainability, how to assess and evaluate life cycle costs of roadways under different construction and maintenance scenarios. We shall have open discussions, questions and answers. So all the questions you're not able to ask, or maybe when you go home and you go through your materials, you may have one or two questions. And then we shall be having the award of certificates, and then we'll take that general group photograph for the course. Ladies and gentlemen, it's been a wonderful time with you for today. We'll continue tomorrow. May I now invite Engineer Issa Usman Imoabinu, Fellow of the Nigerian Society of Engineers, Fellow of the Nigerian Institution of Highway and Transportation Engineers, to come and tell us that thank you, and read out to us what we shall be having or any information for us. Thank you.
Ladies and gentlemen, my dear colleagues, I'm sure you will agree with me that we've had a good day today. That's, we had a decision to see if we could box ourselves in here for 4 days. 3 is down now, our remaining 1. And that one is for tomorrow. As he has already told you, what we have is scheduled to carry out. God willing, we will do exactly that. There is a list that is going around, a list of all the participants for this training workshop, where you are entitled, or you are supposed, or you have the chance to write your name exactly the way you want it to appear in the certificate. We used to have issues, or when you come to register, you just write something that looks like your name, and when we put it in the certificate, you later tell us, no, we need it this way. Now you have an opportunity to write your name precisely the way you want it in the certificate. The Secretariat told me that they have been doing this for the past 2 days. Today is the last day. As from tonight, the certificates we begin to be writing up the certificates. So please make sure you do it before you leave today. If you are not aware of that list, or you've not written your name for certificates, please make sure you stay behind and give the Secretariat your name for certificates. The format for writing that name is a bit different. It's in box. We want to be sure of your spelling. Make sure you comply with that, because that will enable us to be sure that we are able to conclude early by tomorrow. Most of the program we have already is going to remain practically the same for tomorrow until about 4 o'clock. 4 o'clock, I believe that we'll be ready to do something like a closing ceremony, at which we are now going to be giving out the certificates. And we are going to expect to have amongst us some of the dignitaries. 1 or 2 ministers have shown interest of coming to help us to do that. But you know their itinerary can change anytime, but at least 1 or 2 have showed sufficient interest. We also are expecting, you think they asked the people from the Federal Ministry of War to raise their hands today?
No, they did.
Okay, they did. Can you raise your hands for me if you are from Federal Ministry of Works? What of FEMA? Nibri? Ministry for Rural Development. Ministry for Rural Development. Regional Development. The RAM. The delegate from Ghana. You were 2, okay, you're still 2. And of course, the delegate from where? Keystone Bank. We appreciate every one of you. We really feel elated to be part of being able to give this service to the professional community. Like I said, the training will continue tomorrow, and we hope to round up by tomorrow. Please make sure you have your name precisely the way you want us to put it in the certificate. And there's a Google group that has already been formed. If you think you have any question on any of the courses we have taken since on Monday, please put your questions on that Google group, and it will be answered. And perhaps, if we need more detailed explanation, that explanation will be given tomorrow before the final closing. Thank you so very much for your patience and cooperation. Thank you.
Yes, we are starting 9 by tomorrow. Just for emphasis, there is a WhatsApp group created. Not every one of us is on that group. And we are doing giveaways on that group. Please ensure you are part of that group. Very important. I equally want to recognize, I'm sorry I missed this recognition. We have in our midst, once again, the Vice President, Professional Development for the Nigerian Society of Engineers, Engineer Aluya Dauda Engineer Dr. Aluya Dauda Okoduga, Fellow of the Nigerian Society of Engineers. Thank you very much. Please, can we be upstanding as we close with the 3rd stanza of the national anthem? Together we pray, O God of all creation, grant this our one request. Help us to build a nation where no man is oppressed, and so with peace and plenty, Nigeria may be blessed. Amen. Please have a wonderful night rest.